So here we have what I would consider to be a very challenging optimization problem. So it says that the figure above, actually it's to the side, represents a square sheet of cardboard with a side length of 20 inches. So the first thing that we know is that this side is 20 inches and this side is 20 inches. It's going to help us in just a minute. So then they're going to fold up this, they're going to cut out the white pieces there and use the shaded regions of this cardboard to fold into a box that has a lid. So I think the important part of this problem that'll make it a lot easier is being able to visualize what it actually is they're making it into. So it actually is becoming a box. In this box, each of these little heights is actually going to be X. They're folding up these little flaps right here. So you have these flaps there. The other thing is that we have a, this I'm going to call my width W. I'm going to call this my length. X actually is equal to my height. That might help us out. So the width is going to be this length right here. The length is going to be that. So we would like to either find the maximum or minimum volume. And I'll mention this before, but I'll talk about it again later. It's always a good idea to think about what is the domain of your problem, or you can think about the range too, but the domain, remember your X needs to be at least 0. One thing I want you to think about is that the maximum thing that you can have for X, you actually can't have anything, you can't have anything 10 inches or higher. If you were to have X equals 10, there would be no length at all. So X is going to be somewhere between 0 and 10. That's actually going to help us out later. Or you can even think that that's going to help us out now, because in these, you'll notice that you have X equals 10 inches is going to give a minimum or maximum possible volume. That's actually not even going to work for us. So you can automatically eliminate those first two choices. But we'll talk about that later on. Okay, so back to the problem that we have at hand. So we know that they tell us the volume, which you probably know, is given by length times width times height. Our goal is to figure out at which X value is the box going to have a minimum or maximum possible volume. You might be able to guess that it's most likely going to be at 10/3. So if you can figure out that that's going to be your answer for X, you could bypass a lot of extra work. But most likely, you will probably need to actually work out this whole entire problem. So in order to figure out where our volume is a maximum or a minimum, you're going to want to write the entire volume equation in terms of X's. So the first thing that we already know, and I mentioned it a few minutes ago, is that X is equal to H. So that's the first step. We're doing okay so far. The second thing that you might be able to notice is that this side is L, this is X, this is X. Actually, if you add up these three things, that gives you 20. So you might realize that L plus 2X is equal to 20, which gives you that your length is equal to 20 minus 2X. So if you could figure that out, you're off to a pretty good start. The last thing that we have is this width. So I have, this is X, this is W, this is another X, this is another W. So we can use that to figure out our, we know those add up to 20, and use that to figure out our width. So we get X plus W plus X plus W is equal to 20. If you solve this whole thing out, you should end up getting that your value of W is equal to 10 minus X. So now that we have that, we can actually write out our V equation. And I'm actually going to write it over to the left a little so I have enough room. So I know it's length times width times height. My length is 20 minus 2x. My width is 10 minus x. My height is just x. So I'm going to let you multiply that out on your own. When you multiply it out, though, you will find that it ends up simplifying down to 2x cubed minus 40x squared plus 200x. And now that you have an expression for the volume, you can take the derivative. You could have actually taken it up at this step right here, but it would have been a lot longer. With the polynomial, it's easiest just to multiply everything out. So when you take the derivative, you get 6x squared minus 80x plus 200. And we're going to set that equal to 0. If you set that equal to 0, then you can also factor that. And when I factor this out, I get 2 times 3x minus 10 times x minus 10. That's going to be where, if you look back at the choices, the 10 over 3 and the 10 come from. So now we're going to look at we have to do the critical point testing that we've done in the past. We do have, unless you were able to eliminate something, which we kind of sort of did, but I'll just talk about it anyway, even if we didn't. Unless you were to eliminate something, you would have to do a sign chart with all values less than 10 over 3, all values between 10 over 3 and 10, and all values greater than 10. I do, however, want to point out, this is talking about the domain again, that if you had values where x was greater than 10, if you were to look back at your length, first of all, if x was equal to 10, your length would be 0. If x was greater than 10, your length would be negative, so these values actually don't make sense. So we can kind of eliminate that part right away. So just be careful about that. You might figure out in the end that when you do this, it seems like you have two possible answers, but you actually don't. So the best way to do this is to just test your points. I know that 10/3 is the same as 3 1/3. If I choose something less than 3 1/3, by the way, it has to be greater than 0. Look at this right here. I'm going to just use this equation right here. I can plug in like 2 or something like that. I do end up getting a positive if I plug in 2. For the next part, I can plug in like 4 or 5 or anything like that. If I do that, I do get a negative. What that means is that there is a maximum, because my graph is going up and then down. That's what the plus means. Derivative is positive, it goes up. Derivative is negative, it goes down. So at x equals 10/3, that is going to be a maximum. So the answer for this one is D. The second problem is another fairly challenging optimization problems. So I think it's mainly hard to understand what we're actually looking for. We want to know the line with the maximum slope that passes through this parabola y equals x squared minus x plus 16, and also passes through the origin. So we have a few things about this line that we know. So first of all, remember, a line is y equals mx plus b. If you read through the choices, which you should do if you get a multiple choice problem like this, you'll notice that we're looking for the line with the minimum slope. So we are trying to find the smallest possible m. So we want a minimum slope or a minimum m. That's what we're looking for. So we know a few things about the equation of this line. The first thing that we know is that b is equal to 0. That's going to be really helpful because we know it passes through the origin. The second thing that we know is that it intersects the graph y equals x squared minus x at this point, xy. So that's going to also help us. So let's go ahead and start by writing so we know y equals mx. M is the thing we're trying to minimize. That means that we need to solve for m, and then we're going to have to take the derivative of m. So I get m equals y over x. And now I can write this in terms of one variable. So we want to keep in mind that this point xy lies on both y equals mx, and it also lies on this parabola. So what we can do is we can rewrite this as m equals x squared minus x plus 16 all over x. From there, I'm going to, then I can take the derivative of the m, but first I should simplify this fraction a little bit, because otherwise I'm going to have to use the quotient rule, which is better to not use unless you absolutely need to. So I end up getting x minus 1 plus 16 over x. I'm going to rewrite that as x minus 1 plus 16x to the negative 1. Now I'm going to take my derivative to find the minimum slope, and I get 1 minus 16x to the negative second power. The last step for these ones is to set your derivative to 0. I end up getting 16 over x squared is equal to 1, which gives me x squared is 16. In an equation, it's okay to have negative x values. However, we have a nice domain at the top that tells me that x is between 1 and 8, so the negative 4 is not going to work. So I just get x equals 4 is going to be my point where I have either a minimum or a maximum, but hopefully a minimum, because if it was a maximum, that means I did the problem wrong. So I'm just going to double check. You might be able to guess, though, that the answer is, without doing any more work, that the answer is actually going to be B. If you're pressed for time on the AP exam and you get x equals 4, you can automatically stop and just go ahead and just circle B. But we will double check to make sure it's a minimum. You can check that by choosing any test point less than 4, but you still want it to be in the domain, so it has to be greater than 1. And then the same thing here. This for the greater than 4, it still needs to be less than 8, because it has to be within that domain we have up there. So I'm going to go ahead and choose maybe like 3 or something like that. Actually, I'll choose 2. That one's a little bit easier to work with. If I choose x equals 2, I will find that this is a negative. If I choose something greater than 4, if I choose like 5 or something like that, that does give me a positive. So that does mean that there is a minimum at x equals 4.